Hey there, going to go over adding and subtracting mixed numbers. All right, so starting off with the addition, we have 2 and 3/4 plus 1 and 3/4. So we always want to start with our lowest place value. We can think of fractions as its place value because we convert it to a decimal, it would be to the right of that decimal place. So looking to add our fractions, we have 3/4 plus 3/4. Well, we could add these together because we both have fourths. They're both in fourths, so we have the same size piece. So we're just adding how many fourths we have. 3/4 plus 3/4 would give us 6/4. And then we can go ahead and add our whole numbers, and we have 2 plus 1, which is 3. So we get 3 and 6/4, which does look like it's a mixed number. But inside this mixed number, we have a fraction greater than 1 here. So we're going to need to make sure that we don't have this fraction greater than 1. We can have this answer as a proper mixed number or as a just a fraction greater than 1. So one thing that we want to think about is, well, how many holes do we have in 6/4? How many sets of 4/4 are there in 6/4? And then if we could figure that out and regroup, that's great. But if we're stuck, we can always go ahead and do a model. So we could just do a model for 6/4, or we could do it for 3 and 6/4. Since it's 3, I'm going to go ahead and just do a model for 3 and 6/4. So here's 1, 2, 3, and then let me do my 6/4. So I need to decompose this into fourths here. So I do 1, 2, 3, 4. So I have 4/4. I need to get to 6/4. That means I need to do a whole nother model here again in fourths. Here's 4/4, 5/4, 6/4. So here's my model for 3 and 6/4. Well, what is 3 and 6/4 then? Well, how many holes do we now have? We have the 1, 2, 3 from here, but this 6/4 has an extra 1 hole in it. So this is really 4 holes. This would be 4 with 2/4 left over. 4 and 2/4. We could have also decomposed the 6/4 into 4/4, which is 1 hole, plus 2/4, bumping that 3 up to 4 because this is 1 with 2/4. But the other reason why I like doing models is because now if I want this as a fraction greater than 1, all I have to do is think about, okay, well, if I have 4 holes here, how many fourths is 4 holes? And maybe we know if we have 4 groups of 4/4, that's 16/4. But say we forgot how to multiply or something, well, we could take this and just decompose these into fourths as well. I'm not changing the value, I'm just decomposing these into fourths. And now I can just count up the fourths 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we could have also written this as 18/4. These are all equivalent. All right, so that would be adding. Now with subtracting, we're going to start in the same place. We're going to start with our fractions. So we have 7 and 2/5, and we're taking away 5 and 4/5. Well, I can't take 4/5 away from 2/5 because 4/5 is greater than 2/5. So this is where we get to stop and do two different and possibly think about what to do. So one thing that I like to do is think about using a number line to help us count up. Strategy that I learned many years ago. So when we're counting up, we're starting with our number that we're subtracting. We're counting up to the number that we're subtracting from. So I'm going to start with 5 and 4/5. Now this isn't going to be a number line that's perfect. I'm just using this as a tool to help me. So it's kind of like a modified number line. Well, counting up with 5 and 4/5, that's a little difficult. So what I'm going to do is I'm going to go to that next whole number because counting up from 6 is a little easier. So if I'm at 5 and 4/5, what do I have to add to get to 6? I'm really filling out this last fraction. Well, if I add one more fifth, that would give me 5 and 5/5, which is 6. So now that I'm at 6, I want to count up to 7 and 2/5. Well, if I'm at 6, let me just go ahead and jump right to 7 at this point. So I'm at 6 holes, now I'm going up to 7. That's adding 1 hole. And then, so I'm at 7, I need to get to 7 and 2/5. Well, that's just one last jump I need to do, which would be 7 and 2/5. So what did I add to 7 to get to 7 and 2/5? That would be 2/5. So I've successfully counted up in jumps, and now I just need to count. I need to add up. I need to add up all of my jumps. I have 1 whole, 1/5, and 2/5. Well, that would be 1 and 3/5. So my difference would be 1 and 3/5. Now, we could also solve this with regrouping. So let me rewrite this problem. 7 and 2/5, and we're subtracting 5 and 4/5. So Trying to, again, take 4/5 away from 2/5, can't do it. So I'm going to regroup. So I'm going to take the 7 and I'm going to regroup it into 6. So we had 7 ones, now we have 6 ones. And I'm going to bring over 1 whole to this 2/5. But I have to remember on the side, 1 whole, I want to think about it as a fraction. And since we have fifths, 1 whole is 5/5. So I'm really bringing over, I'm regrouping 5/5. I took 1 whole and made it 5/5. Well, I already have 2/5 there. So if I'm adding 5 more fifths, now all of a sudden I'm going to get 7/5. So 6 and 7/5 is really the same thing as 7 and 2/5. I just regrouped it a little bit. And now we can subtract. 7/5 minus 4/5 would be 3/5. And 6 minus 5 would be 1. Again, getting that same difference. All right, so those are the 2 different strategies that we can use for subtraction. For addition, it's pretty straightforward. You just may have to do some regrouping because we may get a fraction greater than 1 here. So we may have to bump up those whole numbers. All right, hope this video helps. Thank you.